So welcome back to T.T.T Academy YouTube channel. I am Chaithra. In this session we are going to discuss electric charges and fields. So this is the first chapter of second PU students. Before starting our session, you just see a famous quote saying, "A little progress each day adds up to big results." So you just take your own motivation, start your day, start your preparation from the day one itself. At the end of your day, when you're when the results will be announced, you will be achieving your goals. So we'll start this session, students. The first topic will be electric charges. So in this chapter we are studying about electric charges. So we'll see what is electric charge. Before that, the study of electric charge is nothing but electricity. So electricity is a branch of physics which deals with the study of electric charges, and this branch is divided into two types. One will be static electricity and another one will be current electricity. So static, the word static means it is a when charges are at rest, or static word refers to rest, and current refers to motion. When charges are in motion, it can produce magnetic field. When charges are at rest, it can produce electric field. So in this chapter we are studying about electric charges and fields. In since we are dealing with the electrostatics. Okay, so we'll see the history development of electricity. So one of the scientists named Thales of Miletus, he is a person, you can see in this picture, students, glass rod and a silk cloth. Both are insulating surfaces, or both are insulating objects. When both are rubbed together, one of the object will be get electrified, or it will get charged, and it will be having the property of attracting the light objects. It may be dust particles, or it may be a piece of papers. So this is what, from this phenomenon, the word electricity is introduced. So these are the examples of static electricity. You can see lightning is also one of the examples for static electricity. And then here a person, when he touches the doorknob, he feels sudden shock. Why? Because charges will be transferred from this object to that object. So when electrons transferred from one object to another object, he'll be feeling that sudden shock because of static electricity. These are the examples. Okay, we'll see what is electric charges. So it is a property of matter by which it can experience and produce the electric and magnetic field. As I told you, when charges are at rest, it will be producing electric field. When charges are in motion, it will be producing magnetic field. So this is what electric charge is. It is the property of matter by virtue of which it can experience and also it can produce the electric and magnetic field. So SI unit of electric charge is coulomb, and we all know that charges are of two types. One will be positive and another one will be negative charge. So we'll see the properties of electric charges. So charge is transferable, charge is conservative, and then charge is additive, and also like charges repels and unlike charges attracts. More properties are there. Among them we will be studying only the basic and important properties here. So this is one of the property of electric charge. You can see charge is conserved. What do you mean by charge is conserved? As we know that energy or charge will it cannot be created by anyone or it cannot be destroyed by anyone. So total charge of an isolated system always remains constant. In this figure you can see here neutron is there, proton is there, electron is there. Charge of the neutron is always neutral or zero. When neutron decays into proton and an electron, proton will be positively charged and electron will be negatively charged. Both will get cancelled each other, and then you will be getting the total charge will be zero. So this is what charge or conservation of charge is. And the second property is charge is additive. You just see in this picture, this is a system. In this system we have number of charges present in this system. If you want to find out the total charge of this system, you can add all the charges present in the system. So it is nothing but the total charge of the system is equal to algebraic sum of all the charges present in the system. So charge is quantized because Charges can take only discrete values, not the continuous ones. So you can see here, Q is equal to plus or minus NE. N is nothing but integer, E is the charge of an electron. All the free charges will be having integral multiple of E because it can take only integral values or discrete values. So charge is quantized. This is also one of the property. You just give the values for N, 1, 2, 3, all those things up to N. Okay. Then the last property will be like charges repels and unlike charges attracts. So this is the basic property we know. You can see in this picture, like charges always repels each other and unlike charges will be attracting each other. So next is Coulomb's law. So what is Coulomb's law? It is nothing but the force. See in this figure, you just see the figure. Here two charges are there and these two charges are separated by the distance r. So the force between these two charges is directly proportional to product of two charges and inversely proportional to square of the distance between them. You can see here F is directly proportional to product of charges and it is inversely proportional to square of the distance between them. And that proportionality constant is taken as K. The value of K is 1 by 4 pi epsilon naught. So this is what Coulomb's law states. Superposition principle. So according to superposition principle, the total force which is present in the system will be equal to sum of all the forces present in this system due to the point charges. So you can see, or you can consider a system of point charges. You can consider a system and here you will be having n number of point charges and they are separated by a number of distance respectively. And you can see if you want to find out the force at F12 position, it will be 1 by 4 pi epsilon naught Q1 Q2 by R12 square R12. So we are using Coulomb's law and according to Coulomb's law we have defined the force, the value of force for this case. And if you want to find out the total force of this system, it will be algebraic sum of F12 and F13 and here you can see the equation which we have written, it is given here. And then if you want to find out for n number of charges, it will be 1 by 4 pi epsilon naught will be kept same and here Q1 is also kept constant. But here Q2, Q3, Q4 up to n terms it will be varying. So you just take a summation and you just give the value of I. Like from 2 to n you can vary the values and Qi by R1I square. So this is what superposition principle says. It is nothing but the total force which is equal to algebraic sum of forces present in this system. Okay, next point is electric field. So in this chapter we are dealing with electric charges and electric field. So up to that concept we have completed that electric charges and in this concept we are going to deal with electric field. So we'll see what is electric field is. It is the region in which charged particles will be experiencing electrostatic force. So that is what electric field is. But when you are defining electric field strength mathematically, it will be the force experienced per unit charge. That is okay. So we have discussed the concepts electric charges. So we'll discuss now what is electric field. It is the region in which charged particles will be experiencing electrostatic force. So charged particles will be experiencing force. So that region will be called as electric field. Mathematically, if you want to define electric field or electric field strength, it will be, here you can see it is the force experienced per unit charge. It is F by Q and SI unit of electric field will be Newton per Coulomb. So as you know, force will be Newton and charge will be Coulomb. So Newton per Coulomb. So this is the SI unit of electric field and electric field is a vector quantity because it depends on direction as well as magnitude. So the final expression for electric field is E is equal to K into Q by R square. So K is nothing but 1 by 4 pi epsilon naught. E is equal to 1 by 4 pi epsilon naught Q by R square. This is the final expression for the electric field. So we'll see electric dipole. What is electric dipole? Here you can see in this picture two charges which are separated at a small distance. So it is nothing but a pair of equal charges which is separated by a small distance is called electric dipole. Using this concept you can define electric dipole moment as well. So before that we'll see the examples for electric dipole? It is carbon monoxide, HCl, ammonia and molecules of water, because in those molecules you can see one like if you consider the case of carbon monoxide, carbon will be positively charged and O will be negatively charged. So it is a pair of equal charge, equal and opposite charges separated by a small distance. So now we'll see what is electric dipole moment. So in this picture you can see it is the product of charge and the distance between them. So it is P is equal to Q into 2A. Q is the charge, 2A is the distance between those charge, and P is the electric dipole moment. This is what electric dipole moment is. So we'll see electric field lines. What is electric field lines? So electric field lines are the electric field lines are the imaginary lines, or they are the smooth curves where unit positive charge tends to move. In this picture or in this video you can see a charge is moving. So these are the smooth curves or imaginary lines. They are not real ones, they are in imaginary lines. In this picture here you can see a pair of equal and opposite charges, but in this case charge will be start at that positive end and it will be ends at this negative end. So this is what electric field lines is. You can see the properties by studying about them. So properties are they do not form any closed loops and they do not intersect with each other, or they do not interact with each other. And when it comes to positive charge, the field lines will be start from the charge itself. You can see in this picture. So from this point it will be starting and it will go to infinity. So during the case of positive charge, but when it comes to this case, charge will start at this point, positive point, and it will end at negative point. This is what the properties of electric field lines are. So now we'll see what is electric flux. So it is nothing but electric field lines passing per unit area through the surface. So you can see this surface is perpendicular to those electric field lines. So electric field lines passing through the surface normally per unit area. So this is what electric flux is. In this video you can see here electric field lines are passing normally or perpendicular to the surface, and the expression for electric flux is electric field and the area. The product of electric field and area gives you electric flux, and this is a scalar quantity. So SI unit will be electric field, SI unit will be Newton per coulomb, and area will be meter square, so Newton meter square per coulomb. So we'll see the very important law in electrostatics, that is Gauss law. So according to Gauss law, electric flux through a closed surface in free charges or in free space will be equal to 1 by epsilon naught times the total charge enclosed by the surface. So here electric flux through a closed surface, you just consider a case of Gaussian surface, or Gaussian surface is nothing but it is an imaginary surface or it is a closed surface. So electric flux through a closed surface will be equal to 1 by epsilon naught times the total charge enclosed by that surface. So the expression will be electric flux is denoted by phi, and as I told you from this law we have an expression Q by epsilon naught. So this is what Gauss law states. If you want more videos you can subscribe to our channel. Thank you.